Okay, today we're going to talk about writing chemical equations. So in chemistry, one of the things that we do is we write chemical equations because it's a shorter, easier way to show a chemical reaction or a chemical change. Okay, so number one, what is a chemical equation? What does a chemical equation look like? What are the components of a chemical equation? So what you're going to find in a chemical equation is usually you're going to find a plus sign and a yield sign. And this is my keyboard way of doing an arrow. So a yield sign is an arrow, and you're going to see symbols and you're going to see subscripts that show ratios. So basically you're going to see, instead of an equal sign, you're going to see an arrow and you're going to see a plus sign. The plus sign might be on this side or it might be on this side. And we use a chemical equation because it's a shorter, easier way to show reactions using symbols. Okay, so this is showing a chemical reaction. This is the reaction of hydrogen and oxygen, and it yields water. Okay, yields is the arrow sign. Now this isn't actually the balanced formula for water because you're going to see that it's actually O2, but we'll get into that later. I don't want to confuse you. But as of right now, we're going to remember that a chemical equation is just like an equation in math. You have your addition sign, and instead of equals, you're going to have a yield sign. Okay, so what is a formula? A formula is actually, I like to think of it as like the recipe to the substance. So in this case, if you want to make water, what is the formula for water? Well, the formula for water is 2 H's and 1 O. And if you combine them, you're going to get water. So in order to make water, you have to have 2 H's and 1 oxygen chemically combined with a chemical bond. So a force is like a word that represents a compound. So this is the shorter way of writing the word water. So we could write the water out, or we could write H2O, and it's a shorter, easier way. And it uses a symbol and a ratio. Now again, difference, you've got a formula, which is the H2O, and you've got an equation, which is formulas, a plus sign, and a yield sign. So an equation is like an equation in math, and a formula is just like one word. So what do they show? A formula is going to show what elements are being used, and it's going to show how many of each element, the ratio. So if you look at aluminum chloride, and the second letter is lowercase, so I know it belongs to the first letter. If the second letter were uppercase, that means that'd be two different elements. But since this second letter is lowercase, it belongs to the first letter. So this is the same thing as saying the 1 is understood. If there's no subscript there, that 1 is understood to be there. So there's 1 aluminum and there's 3 chlorine. Okay, so the formula for aluminum chloride is 1 aluminum and 3 chlorines. Okay, and that's going to be the formula. So the formula tells you in order to make aluminum chloride, you need 1 aluminum and 3 chlorides. Now just a reminder, in this case, there are 2 elements, but there are 4 total atoms. See, as you can see, there's 2 different types of elements involved, but there's 4 total atoms. Okay, so a subscript. When you talk about the word subscript, The prefix sub means under, like submarine, and script means writing. Okay, so subscript is the underwriting. It shows the ratio of elements in a compound. So we have a 2:1 ratio in this subscript. Okay, so, sorry. Okay, so we have a 2:1 subscript, or a 2:1 ratio. The 1 is understood to be there. We don't really write it out if it's just one atom of that element. So this means that I have 2 hydrogens, excuse me, to 1 oxygen. And again, sub means under, and script means writing. And you can see that the subscript, okay, is smaller than the symbol. It's a smaller writing. So you could write the subscript H2O. Do you see how I'm putting it under the writing? You could have CO2. The subscript is under the writing. Okay? So what if a symbol in a formula doesn't have a subscript? Again, the number 1 is understood. If there's no, okay, the number 1 is understood to be here. Sometimes people just write it to keep from getting confused, but you don't have to. If there's just one of them there, then 1 is understood. So this is carbon monoxide. Okay, it means you have 1 carbon bonded with 1 oxygen. So what is reactant? Okay, reactants are what you begin with in a chemical reaction. Okay, you're going to start with the reactants. So if I were going to make water, okay, if I were going to make water, I would start off with a diatomic hydrogen molecule, and I'd add a diatomic oxygen molecule. It's going to add those together. Well, what's going to happen is I'm going to yield, and it's actually going to yield an H2 O plus an O. Okay, so I have to have another oxygen here, and I'm going to not stick with this because we're going to go ahead and talk about your how these things are going to balance out. What you start off is what you end with. So I have 2 hydrogens, and 2 hydrogens, and 2 oxygens, and 2 oxygens. But reactants are always going to be on this side of the arrow, and the arrow always is going to point to the products. Okay, so let's say that we're making cake. So in order to make a cake, we're going to use cake mix, eggs, water, and oil. And all of these are going to react together. So these are going to be your reactants. They're going to react together, and they're going to yield the product. And the product is going to be cake when all is said and done. But these are your reactants. These are the things that are going to work together to make the cake in the end. The yield sign means I'm going to add energy. Okay, so when I put it in the oven and add heat, I'm going to have cake. So the product is what happens when the chemical reaction is complete. So if I add if I add that oil and the egg, sorry, let's go back a second. If I add the cake mix, the eggs, the water, and the oil, then I'm going to get cake. Another example, okay, if I have H2, my screen keeps wanting to change, sorry about that. If I have H2 plus O2, then that's going to yield H2O2, which is hydrogen peroxide. So if I take diatomic hydrogen and diatomic oxygen, I'm saying diatomic, let me just put this over here so you know what I'm talking about. That means 2 atoms. And see, I've got 2 atoms of hydrogen and 2 atoms of oxygen. So if I have diatomic hydrogen and I add it to diatomic oxygen, then I'm going to get hydrogen peroxide. It's going to yield. So my reactants are going to be over here, and my product is going to be here. So the arrow always points to the product. Okay. So how is a chemical reaction, or how is a chemical equation written? The standard formula is reactant plus reactant yields product plus product. But it's not always going to be written that way. See, in this case, you've got a reactant on this side and 2 products. So if I were to go into my medicine cabinet and I would get hydrogen peroxide, which is H2O2, and I were to let it sit for a really long period of time, that hydrogen peroxide is actually going to decompose. It's going to break down. It's going to decompose. So I'm starting off, my reactant is hydrogen peroxide. I only have 1. And it's going to decompose into water and oxygen. So those are going to be my products. So if you go in your medicine cabinet and you put the hydrogen peroxide on your injury or your abrasion, it's not going to fizz anymore because hydrogen peroxide decomposes over time. So when the expiration date says it's time to replace it, it really is time to replace it, because basically what you now have left in your medicine cabinet is water and oxygen. So my chemical equation, the standard formula is reactant plus reactant yields product plus product, but it can be written reactant plus reactant plus reactant plus reactant yields 1 product, or reactant yields product plus product. So you can see it in multiple different ways. This is just the standard formula. Now, law of conservation of mass. This states that matter cannot be created nor destroyed. Okay? It is a law, and a law states in science that it has been proven. And the law of conservation of mass says that what I start with, I have to end with. So matter is not created nor destroyed. Okay? So if I put cake mix and oil and water and egg to make cake, well, if I didn't put chocolate chips in the beginning, I'm not going to get chocolate chips in the end. And if I put an egg in the beginning, the cake has 1 egg in it, not 2, not 3. I just put 1 egg in. So what I start with in the beginning, I have the same amount in the end. It's just in a different format. It's in a different appearance. It's in a different look. But I still just have my 1/4 cup of water, my 1 egg, my 1/3 cup of oil, and my cake mix, and they make the cake. Nothing's created once I put it in the oven. When I put it in the oven, I'm not magically going to get chocolate chips out of it. What I start with, I end with. It's just in a different way. So this is why we have to balance equations. Okay, and an equation is balanced when you have the same number of each type of atom on both sides of the equation. So what does that mean? That means if I have a hydrogen, or if I have hydrogen peroxide, and I were to count, I have 2 hydrogens and 2 oxygens. Okay, so this is 2 hydrogens and 2 oxygens. Okay, that's a molecule of hydrogen peroxide. Over time, it's going to decompose into water and oxygen. Water and an oxygen. If you notice, the law of conservation of mass states that if I started with 2 hydrogens, I have to end with 2 hydrogens. And if I started with 2 oxygens, I have to end with 2 oxygens. Now it's not still hydrogen peroxide, now it's water and oxygen. But I still have the same number and the same type of atoms. Notice I didn't stick a carbon in here because I didn't start off with any carbons. So there can't be any carbons in the products. And so what I start with, I have to end with. But it can be in a different chemical formula. It's still just the same number of hydrogens, 2 and 2 and 2 oxygens and 2 oxygens in the product side. So what I have on the reactant side, I have to have on the product side. Now, in math, you're going to use a coefficient. Okay, so if we're talking math, 2x equals 8. 2 is your coefficient, right? It's the number you put in front of a variable. Well, we can use the same thing in science. It's a number placed in front of a chemical formula. So if I put a 2 in front of H2O, that means this coefficient means that I have 2 water molecules. Okay, so a coefficient tells you how many molecules you have. So if you put a coefficient in front of a formula like H2O, it tells you how many water molecules you have. Okay, now you might have some more notes on your page about synthesis and decomposition and replacement. You do not need to know those, so you can cross the rest of those notes out, and I know you'll gladly do so. If you don't see any more on your page, I've had the opportunity to already delete those from your notes.